everyone, this is Priya and today we will see problem number 729 from the Leetcode, that is my calendar first. Okay, so this is a medium level problem. So let's check out the problem. We are implementing a program to use as calendar. We can add a new event if adding the event will not cause double booking. So what we have to avoid? We have to avoid double booking. Let's check what is double booking. Double booking happens when two events have some non-empty intersection. When two events, when the duration of two events intersect with each other, then double booking will happen. And we have to avoid this. We don't have to book two events at the same time. Okay. One more thing is they have mentioned that the input will be in the form of start and the end is open-ended. That is, the ending time of first one event can intersect with starting time of another event. That is, if one event is ending at some time, then at that time the other event can start and we can book those two events simultaneously. Okay, so what are the tasks? Two tasks in this program. First, we have to initialize the calendar object in myCalendar class. The second thing is we have to implement the code for the book method, which will return true if the event can be added to the calendar successfully without the double booking. Otherwise, it will return false and we do not add the event to the calendar. Okay, so let's check what this means is first check what intersection means. Let's say this is one event at 10 and 20. Okay, and we have one more event at 15:25. 15 to 25. So first booking came for 10 to 20. So we have booked. We have written true. We have available slots for this time. So we have written true and we have booked for 10 to 20. The next booking came for 15 to 25. Then first we will check that the starting time of new booking is 15 and we have already booked till 20. Okay. So this uh, 15 lies somewhere here, but this time we have some another booking. So we will retain false for this booking, that we can't take your booking this time. Okay, the next booking comes is 20 to 30. Now let's check out this. This comes, the first booking we have booked is ending at 20 and the next booking is the new booking came is from 20 to 30. Okay, so what we have seen in the problem that we can accept the offer if the ending time of one event is the starting time of another event. So we will return true for this and we will accept the offer. So that's how we have to check that whether we can book or not. Okay, so there is one condition we have defined for this, for the linear approach. Okay, that for when intersection will occur, when this is the new event we are getting from the customers and this is the event we have already booked for. Okay, so what we have to check that if start time of we have booked st is less than ei. Okay, if our ei is greater than st, then ei will lie somewhere here. This is ei. Okay, and if and si, that is start time of the input booking, is less than end we have already booked for. Okay, this, so if this is the case, then intersection will occur. then we have to return false, that we can't book for your booking. We have to return false for this case. Okay, so let's check code for this approach. uh, this will have a very high time complexity because it is order of n square. We have to iterate, we have to check, we have to compare every booking with every booking we have already booked. Okay, so this is a brute force approach, and but we can check the problem accepted by Leetcode. So first in the constructor we have initialized the bookings object. Then for each input start and end, we have checked in our bookings object, for each object in our bookings, if this condition, if our end is greater than s, the start of the already booked object, and if the a new start, the start is the new event, and e is the already booked or end of the already booked object. Okay, so if end is greater than s and start is less than e, then we will return false. Okay, so this is how we will uh, consider all the intersection cases, and if it's not the case, then we will append the object in the book or a booking object and return true. So from this, your all the test cases will get passed. But as I said, that it will take a lot, order of n square time complexity. Okay, that one is a linear search, so we need some other search. So what we can think is, we can use binary search tree. We can use binary search tree, which will have a time complexity of order of n log n. So how we can do that? First, the first node we have received, we will make it root node 30, 50. Okay, this is our first node. Then next booking come for 10 and 20. Then what we will check? We will check the ending time of the new booking is greater than starting time of the root node. Okay, root node is 30, 50. So ending time is 20 and starting time is 30. So we have to check leftward. So somewhere here, if there is no node available currently, then we will add 10 to 20 here. We will book this slot. If there is some node present already there, then we will check again with that and retain it accordingly. Then the next slot come for 15 to 25. Now what we have seen that we have to check the ending time. Ending time here is 25, and starting time for the root node is 30. Okay, so this is where we decided we have to go leftward. We have to check here. Now we have already this node. Okay, now first we will check here it will become 10, 20, and our new node is the case will be like this. New node is 15, 25. Now what first we are checking? We are checking for leftward. We are checking that if ending time of the new node is greater than starting time of the current node, but less than the starting time of current node. Okay, but this is not the case. This is greater than 25 is greater than 10. Then what we will do? We will check with the ending time of the current node. Is 25 is greater than 20, then this node 15 and 25 will come here. Okay, so this is how we will make. So in Python, in Java there is a data structure called tree map, but in Python there is no data structure for that. So we are creating our own binary search tree. First we are creating a node. Here is the constructor. it will have a start and end, and one left pointer, one right pointer. Okay, so we have initialized start with start and end with the end when we will initialize the object, node object. Then we have an add node function. Okay, this is for the left, going to the towards left. So if node dot end is less than equals to self dot start, self is a root node, okay, our booked object, and node is the our new booking. Okay, if this value is less than equals to self dot start, then we will go inside. Now what here we will do, we will check self dot not self dot left. If self dot left is none, that is it is a root node. Okay, we are initializing the our tree first time, that is self dot left is none. Then there is no node towards left. Okay, in the root node self dot. Then we will make that self dot left equals to node and return true. Else we will call self dot left for that root node. Okay, then else if, now this is the case for the right side, we are checking for the right half tree. The same is if not self dot right, then we will assign self dot right to node and returns true. Else we will call self dot right dot add node. We will add node on that right node if there is a node already present. Then if no condition like that, then we will return false, that we can't add. Okay, so this is where we have initialized in the constructor self dot root equals to none, and then second we have implemented the code for book. If not self dot root, if self dot root is none, that is the tree is not initialized yet, then we will initialize self dot root equals to node object. We will pass start and end, or start and end to this node constructor, and it will retain a node object, and that will be assigned to a root. Okay, and it will return true that we have added the booking. Now else we will call the, if root is already present, then we will call add node, that we have to add another node in this tree if tree is already created. If tree is not created, then we will add the node to the root element. If tree is already created, then we will add node to that tree. Okay, so we will call the add node function, and we will pass it a node object with start and end element. Okay, this is this will pass all your test cases. Hope you have understood the code. So thank you.